and welcome back for part 2 of graphing in standard form. In this video, I'm just going to do one more example to talk about how we can find information from standard form and how we can graph from standard form of a quadratic. Okay, so just a quick refresher. Remember that standard form is the form of y equals ax squared plus bx plus c. So in the given problem down below, we have a value of a, that's -1, and a value of c, that is -2. Now notice on this problem, there is no x term. So what that tells us is it tells us that the value of b equals 0. Okay, so it's the b value is not the second term. The b value is the coefficient of x. Since there is no x term, that means the coefficient of x was 0, and it has canceled that term out. Okay, so let's continue on. Now, remember, from the equation itself, information that we can already know about our quadratic is we can know the direction of the graph. Since the value of a is negative, that means that the direction of my graph is it's going to face down. Since it faces down, we sort of think about, oh, it's going to look like this. So that means it's going to have a highest point, or what we call a maximum value. Okay. And the other thing that we can tell from the graph is the y-intercept. Whenever it's in standard form, the y-intercept is always 0, c. So the value of c is -2, so my y-intercept is going to be 0, -2. Remember to write your ordered pairs with parentheses and a comma in between. Y-intercepts and x-intercepts should be written as ordered pairs so that you can identify the exact location of them on the graph. Okay, so the other thing that we want to find is I want to find the vertex, which will also help me find the axis of symmetry. I will find the vertex, and I will put the vertex in the middle of my table here. So let's go ahead and do that. We find the vertex by plugging in b and a to the form -b over 2a. Remember, this tells you two things. It tells you the x value of the vertex. It also tells you the equation of your axis of symmetry, since the axis of symmetry will go straight down through the vertex at a vertical line written as x equals, and whatever the x value of the vertex is will be that number there. All right, so let's go ahead and plug that in. I have x equals -b, well, my b is 0, over 2 times -1. Well, that just gives you 0 divided by -2. Remember that it is okay to divide by 0, but it's not, it's okay to have 0 in the numerator. It is not okay to divide by 0. So the answer to this is going to be 0. So that means that the x value of my vertex is going to be 0. So I'm going to put that here as well. And it tells me that my axis of symmetry is going to be the line x equals 0. Okay? So since we have the x value of this point, we now need to find the y value of that point. And we do that by simply plugging in 0 for x. Plugging in 0 for x is actually really easy. If you can do it in your head, that's great. If not, then go ahead and plug it in. Plugging it in would look like this. When you plug in 0, 0 squared gives you 0. 0 times -1 gives you 0. It cancels that term out, leaving you with a y value of -2. Therefore, my vertex is the point 0, -2. And so then I'm going to pick two x values to either the right or the left of 0. I'm going to go with the values of 1 and 2. So again, you're finding the next two x values next to the x value of the vertex. And you're going to plug those values in to find more points on your graph. So plugging in x equals 1, it'll look like this. It'll be y equals -1 times 1 squared minus 2. If you can plug it in your head, that's absolutely okay. Sometimes people just need to plug it in and then they can go through the steps in their head. That's another way to do it. This is, you need to make sure that you are squaring before you multiply. So it's 1 squared, which is 1. 1 times -1 gives you -1. So this ends up being -1 minus 2, which is -3. So when x is 1, y is -3. I'm now going to plug in when x is 2. When x is 2, it will be y equals -1 times 2 squared minus 2. Again, 2 squared should go first, so the 2 squared is 4. 4 times -1 gives me -4. -4 minus 2 is -6. Okay? And because of symmetry, the other x values directly on the other side of 0. So again, when you're thinking about that, think of a number line. If this is 0, we have 1 and we have 2 on one side. On the other side would be -1 and -2. The y values of these 2 points will be the same as the y values of these 2 x values. Okay, so that means in my table, -1, -2 will be the x values on the other side. And since the x value of 1 was -3, that means the x value one space in the other direction will have the same y value. Since the x value of 2 has a y value of -6, that means 2 x values away in the other direction will have the same y value. So you can see on the first example in part 1, I figured out these other 2 points by using my graph. But you can also figure out these other 2 points without your graph. So whichever way you want to look at it and whatever works best for you, please go ahead and do that. So I'm going to go ahead and graph everything on this. So I have my vertex of 0, -2. That's here. My axis of symmetry. Do my best to draw that. It's actually going to go right down through the vertex. And in this case, the axis of symmetry is the y-axis. Plotting my other points, I have 1, -3, and I have 2, 1, 2, 3, 4, 5, -6. Okay? Remember that we know the points on the other side, but if you didn't, we know that since this point is 1 space away from the axis of symmetry, 1 space away in the other direction, you can see that we get that point -1, -3. This is 2 spaces away from the axis of symmetry. That means that 2 spaces away in the other direction, there's going to be another point, which happens to be that other point we found in our table, -2, -6. We can then connect this and get our parabola. When you draw your parabola, it should be a curve. Make sure that it's not a V-shaped, and there should be arrows at the end indicating that this keeps going on forever and ever. Now you'll notice that this does not cross the x-axis at all, so that means that there are no x-intercepts. So I'm just going to put none. The domain for any quadratic function, since as it goes down or as it goes up, goes out to the right and to the left forever, will always be all real numbers as long as it's a quadratic function, meaning that it faces up or faces down and passes a vertical line test. The range will always be written as y either less than or equal to or greater than or equal to. In this case, it's going to be less than since the graph is facing down. And it's going to be less than or equal to the y value of the vertex, which is -2. So there you have it, a second example going over how to graph a quadratic in standard form. and also how to find all the information that we need in order to have a nice graph. Sometimes they will ask you to just find all this information and not graph it. So, it's nice to be able to fill in this table and fill in this information even without looking at the graph. Okay, so I hope you enjoyed this video and this example helped you, and best of luck with your practice.